Hello and welcome to Calculus. So I was going to run through just a few examples of some basic integration problems. Maybe not so basic, maybe some of them will, but just wanted to give you some examples to go by. All right, so let's say we want to do the integration of x to the, I don't know, let's say 1/2 power dx. Now, something I want to point out here is that when we have fractional exponents, that's the same thing as a root. So these two statements are identical, okay, and how we would need to approach them by plugging values in. But one of the things I do want to point out is this version right here on the left is much easier to deal with in terms of integrating it, because then we can just simply go by the exact same rule we always would. Add 1 to the exponent, which makes that 3/2, and then divide by that new exponent of 3/2, and then plus c. Now, I'm not a big stickler on this, but this one we can reduce a little bit and rewrite this so we don't have a number over a fraction. We can rewrite this as 2x to the 3/2 over 3 plus c. Now, you could continue to rewrite that in a couple other ways, like for instance, you could write this as 2 on the square root of x cubed over 3 plus c. This is perfectly fine for me, but you will run into situations where this will be how the answer is expected, right? Or even 2/3 times x to the square root of x to the third plus c. So there are a couple more ways we could probably write that, and they're all correct as long as you get past this stage right here. This is the correct integration, it's just that there's more we can do with it. Let's look at another example. Okay, so what else? What are the situations we run into? Well, what if we talk about, say, the integration of 1 over x to the third dx? Well, one of the things we probably want to think about is rewrite this as what appears to be a polynomial, because that's really what we did over here. Was if we think of this being a polynomial or power function, this becomes a little bit easier to work with. So let's do the same thing with this one. Let's make this x to the -3 dx. Negative simply moves that base from denominator to numerator, or vice versa, depending on where it's starting from. So I could actually move it the other direction if I wanted to, if it had been in the other spot. So make this from a +3 to a -3, moves it into the numerator, and now I can add 1 to the exponent, which makes it -2. Adding 1 to -3 makes it -2, and then divide by the new exponent. Plus, so we're dividing by -2, and then plus c. Pardon me. And then from there, we can rewrite this in a half dozen different ways. This is acceptable in its final form, but just to kind of make sure that you see the other ways you can write this, we can write this as 1/2 x to the -2 plus c, or -1 over 2 to the x squared plus c. And this would probably be the most common way that would be written right there. All right, how about one or two more examples of some basic integrations for us? Namely, what about this one, say 1 over x dx? Well, you're like, well, we just did a fractional one. What's different about this one? Well, this one in particular, when we do this integration, this becomes x to the -1 dx. Adding 1 to that gives us 0, and then dividing by 0, well, we can't do that. That causes a black hole in the universe, and everything is destroyed, right? So no doing that. But this piece right here is actually a particular definition, and in this case, it's actually ln of x, and then don't forget your plus c. So this would be one of them that you'd kind of want to memorize, because there's not a whole lot of, we can run through the rigmarole of showing the summation. The limit of the summation gives us this based upon those values right there, but we can just do it this way, okay, and just kind of memorize that. Another one to remember is if you have e to the x dx, you get, you guessed it, e to the x, and then plus c. All right, and that's it. Okay, so there's the big ones, and then of course you have some trig ones, just like integration of sine of x dx, whatever the variable might be here. Well, that's just simply going to be negative cosine of x plus c. Now you're saying, well, the derivative of sine is cosine, so the integration of sine would be negative x, probably negative cosine rather. So those are your basic integrations. Some of these you probably just need to memorize, and we're going to go into more details with some others of these, and we have other rules to go through, like integration by substitution, integration by parts, and a few other ways we're going to do this as well. But some of these, that's the basics of where we're going to start with that. All right, take care.